If you are just joining us, this is part 2 of right triangle trigonometry. So you're watching this for a class or you're watching this for your own gratification. This is going to be a little bit more of an exploration into what it means to actually have sine, cosine, and tangent. So part 1 was the basics. Part 1 was saying what is sine, cosine, and tangent. Part 2 is coming at you talking about cofunctions to start. So here we go. When we're talking about cofunctions, we've kind of gone over a couple of things with sine, cosine, tangent, but here, cofunctions look like this. Sine and cosine go together. They're cofunctions. Notice, we have a co in front. Okay? So sine and cosine go together. Secant and cosecant go together. It's got a co in front. Okay? So if you guessed it, tangent and cotangent. You guessed it. It's got a co in front, okay? And so those things go together in this way. Let me show you how this works. Okay, we look at the basics. What is a cofunction? I've got an angle here drawn in standard form. And so we're going to just assume for a second that this is theta. This looks like something we've seen before. For the purposes of this exercise, let's just put something a little bit more familiar to this sine, cosine, and tangent on it. So this is going to be A. This is going to be B. And of course, C is down here. This is going to be our right angle. And so if we recall, we're going to put the little letters opposite the big letters. So I've got opposite sides correlating like that. So let's look at how this works. If I'm asking what is the sine of A, the sine of A is going to be opposite over hypotenuse, or A over C. But look at what happens. I'm going to go down. I'm going to have cosine of B. Sorry, A. Cosine of A is going to be adjacent, B, over C. And the tangent of A is going to be opposite over adjacent, A over B. Now, watch what I do here. It's going to blow your mind. Okay? Stick with me. Here we go. The cosine of B is going to be adjacent over hypotenuse. See how we're relating here? The sine of B is going to be opposite over hypotenuse. The cotangent of B is going to be B, but it's going to be adjacent over opposite, so A over B. I don't know if you noticed what just happened right there, but let me give you a subtle hint. They're the same. They are the same. Now, the distinction here is I've got sine and cosine and sine, tangent and cotangent. But notice, in the previous slide, we just talked about cofunctions. We just talked about how they relate, how they go together. And so, really what we're talking about is this. We're talking about cofunctions. A trig function is always equal to the cofunction of the complement. Think about this. For example, the sine of 40 is equal to the cosine of 50. Because think about this triangle here, guys. Okay? A and B have to be 90 degrees together. I've already got 90. Okay? I've got 90 here. So there's 90 left over for these two angles. So they must be complements. So guys, what I'm saying is the sine of 40 is equal to the cosine of 50. So let's fill in the blanks. If I know that I've got the cosine of 30, I'm thinking, what is the complement? So 60 must go here. Okay? If I've got the tangent of y, now we're going a little abstract. We're going a little algebra on them here. What are we going to be doing here? Let's figure this out. If theta, x or y, whatever the angle happens to be, is unknown, we remember that the complement of y is 90 minus y. So this is going to be the cotangent of 90 minus y. Okay, guys, you see how this works? Okay, and so when I'm talking about cofunctions, I'm talking about the opposites are equal if we're taking the function of the complement, okay? And so here's what it looks like. I've got just a thought for us here, and you're going to see how this works, okay? Now, if I've got a 30, 60, 90 degree right triangle here, I'll mark my 90. I'm going to go 30 here. I'm going to go 60 here. We remember special right triangles. And so everything is based on the shortest side. So I'm going to call the shortest side t because it's opposite of 30. We remember that the hypotenuse is 2 times t, and the longer leg is t times the square root of 3. Now, guys, look at what's happening here. If I'm talking about the sine of 30, watch what happens. It's going to be opposite. Let me give myself a little bit of space here. The sine of 30 is going to be opposite t over hypotenuse, 2t. Guys, let's reduce this fraction. 1/2. Seems convenient. Let's look at it again. The cosine of 30 is equal to adjacent over hypotenuse, t times the square root of 3 over 2t. Let's reduce it here. We've got square root of 3 over 2. Looks pretty convenient to me. Tangent of 30 is equal to opposite over adjacent. Opposite over adjacent. Let's reduce it. Okay? And so look at what happens if I'm going to do the opposite thing. I've got, let's go sine 60 on this side. Opposite over hypotenuse. You see what's happening here? Can you fill in the rest yourself? Do you want to pause this? Adjacent over hypotenuse. Tangent of 60 is equal to opposite over adjacent. Okay, guys, so do you see what's happening here? Do you see what just happened there? So if I'm going to take the sine of 30, I'm going to get 1/2. If I take the cosine of 30, I'm getting square root of 3 over 2. It's a good idea for you to copy this chart down. If I'm doing the tangent of 30, I'm getting 1 over the square root of 3. But look at how these things are related. It's a beautiful thing. The sine of 60 is square root of 3 over 2. Hello? Okay? The cosine of 60 is 1/2. The tangent of 60 is the square root of 3. Do you see what I'm seeing here? Cofunctions everywhere. Cofunctions all over the place. Pairs of cofunctions everywhere. Okay? And so I've got these things that are related, and it's a great thing. Notice I've left 90 blank. We're going to come back to that one, okay? And so when I'm talking about these things, this is a good idea. Memorize these. These are going to continue to come up over and over and over. Memorize this chart. Let's do another little exploration, shall we? What if I did a 45, 45, 90? I wouldn't want my other special right triangle not to feel special. Okay, and so remember, if this is t for the side length, this is t times the square root of 2. Okay, so I've got t times the square root of 2. Now, we only really need to find one. Sine of 45, because the other acute angles are the same. Sine of 45 is going to be opposite over hypotenuse, t over t times square root of 2. I don't know if you're seeing what's happening here, guys, but it's going to be a beautiful thing. The cosine of 45 is going to be adjacent over hypotenuse. Why do you suppose these are the same? They're the same because we've got two of the same angles. So we have two of the same sides. So we have two of the same ratios. Okay? Back to action. Tangent of 45 is opposite over adjacent. Okay? So when I fill this in, I've got 1 over square root of 2. 1 over square root of 2. I've got 1 here. Okay? Beautiful things. Notice these are cofunctions also because 45 is a cofunction of itself. So the sine and the cosine are the same because 45 is equal to 45. So the sine of 45 is equal to the cosine of 45. This is cotangent, or this is cofunctions here. Okay? So as we're going on, let's do a little substitution. Okay? Now we're going to use the table to show that these are 2. Cosine squared 30. Well, we have the cosine of 30 as, what do we put it as? Okay, cosine of 30, square root of 3 over 2. So we've got square root of 3 over 2. I'm going back for reference purposes here. Square root of 3 over 2 squared plus, and the sine of 30 gave us something else. The sine of 30 was 1/2. We're going to square that. Okay? Now, this should be an equal sign here. We're going to show that it's equal to 1. Well, guys, look at what we've got here. It's a beautiful thing because then we've got square root of 3 squared over 2 squared plus 1 squared over 2 squared. I'm breaking down the fractions for us. We've got 3 over 4 plus 1 over 4 is equal to 1. Well, what do we want it to be equal to, guys? 1. We're good. Okay? Let's do the same thing down here. See if you can do it yourself if you'd like. Okay? I've got cosine of 45, which is 1 over square root 2 squared plus 1 over square root 2 squared. Well, look what I've got. 1/2 plus 1/2 is equal to 1. I want it to be equal to 1. Okay? So we're making these things easy for ourselves by substitution. Okay? That's what I've got for you for right now. That's basic trig ratios 2. Right triangle trigonometry part 2. I'm going to go into part 3. It's going to be real short. A couple of examples. Go ahead and watch that one after this one. Thanks for watching.